So today is Tuesday, November 13th, and we are doing Eureka Math Module 2, Lesson 19. Okay, Module 2 is very long, as you can see, but we're almost done with it. We'll finish it soon. Our learning goal today is that we are going to use what we know about estimation, building on from what you learned last week, and also what you know about math facts to help you divide by two-digit divisors. And we'll talk about what that means in just a little bit. Let's start off today with a quick review. What are the parts of a division equation? If I have the division equation 70 divided by 30, the number 70, what do we call that? Everyone? Whole. The whole. Very good. Okay, so this is the whole. What do we call 30? That's who's knocking on the door, right? Okay. And what do we call the answer? Quotient. Quotient. Very nice. Okay. So if today in our learning goal, we said we're going to use what we know about estimation and math facts to divide by two-digit divisors, which number are we talking about? The first number, the second number, or the third number? Second. So today we can expect all of these numbers, all of the divisors, to be two-digit numbers. Okay? Let's solve this problem. 70 divided by 30. Go ahead and write that in your notebook. So in this case, for our estimate, we know that our divisor is 30. Okay? What whole is pretty close to 70 that is easily divisible by 30? Everyone? 60. So we know that 60 divided by 30 is 2. So the estimate tells us that our answer should be pretty close to the number 2. I want everyone to write down this estimate because the key to two-digit division is estimation. Everyone repeat after me. The key to two-digit divisors. It really should be to dividing by two-digit divisors. Say that. Dividing by two-digit divisors. Is estimation. Now that we've estimated, we can actually solve the problem. Which number is living in the house? 70. The whole. Very good. So go ahead and put 70 in the house using the standard algorithm. Who's knocking on the door? 30, or the divisor. Very good. Okay, now, remember when we divide using the standard algorithm, the family comes in to help. Dad, mom, sister, brother. What does dad do? Divide. So he has to say, okay, if I have 70 and I want to divide it into 30 equal groups, how many can I do? Well, when we had our estimation, Dad was smart. He estimated first. He said, you know what? I think it'll be about 2. So should we put the 2 over the 7 or over the 0? 0. Good, because can we divide 7 tens into 30 groups? No. So we have to do 71s. Okay? Now, after Dad divides, what does Mom do? Multiply. Good. Geffen, what two numbers does Mom need to multiply?
The 70.
The what?
The 7 and the 0.
Mom has to multiply 7 times 0?
No.
Dad already divided. He said, if I have 71s and I divide them into 30 groups, I can put 2 in each group. What does Mom need to do next?
Mom needs to minus.
No. Multiply. What does Mom need to multiply? 30 times?
30 times something.
Times what?
Times 2.
Thank you. 30 times 2, which is?
60.
Good. Then brother comes along then sister comes along, and what does sister need to do? Subtract. Okay. What's 70 minus 60?
10.
That means we have 10 left over. We have a couple options at this point. We could say that's a remainder. We could add 0/10 and keep dividing. But for today, we are going to leave it as a remainder. Okay? Now, how do you know when it's a remainder or when you need to keep dividing? Go ahead and talk at your table groups. Okay, now, in order to check our work, we basically we split up the whole of 70 into 2 parts. We said the whole is 60 plus 10. Do you agree that 70 is 60 plus 10?
Yeah.
Okay, so that means that we can check our work by doing 2 times 30. What's 2 times 30? 60, because 60 is 2 groups of 30, and then we have to add 10 more. Whenever you do division, you can check your work by doing the inverse operation. What's the opposite of division? Multiplication. So you'll multiply your quotient times your divisor, 2 times 30, because that's 2 groups of 30, and that'll get you 60. Is that our original whole? No, you have to add the remainder, which was 10, to get your original quotient, or your original whole. And if you do that and you get your original whole, you'll know you're on the right track. Start by copying down 430 divided by 60. Okay. Today I want you to know that there's always going to be the three steps you have to show me. You have to estimate. You have to show me your estimation. Then you have to show me how you solve it. Then you have to show me how you're going to check your work. Okay. So let's start by estimating. Do we need to round our divisor? Or is it already easy to work with? It's easy to work with. So we'll keep it there. What whole is compatible or goes along easily with 60? Does 430 go along easily with 60? No. Is there a number that's pretty close though that would go along easily? Yes? Okay, Aradna. 420. How did you know 420 would go along well with 60? Because you know in your head 6 times 7 is 42. So what's 420 divided by 60? 7. Okay, go ahead and write down your estimate. Whenever it's time to solve, we have to write it in standard algorithm. So who lives in the house? Which number?
430.
Okay. Who's knocking on the door?
60.
Very good. Go ahead and set up your standard algorithm. Now, Dad comes along to divide. The nice thing is Dad can always use your estimation to help you. Okay, I have 4. Can I divide 4 by 60?
No.
Okay, let's regroup. Can I divide 43 by 60? No. Still too small. Can I divide 430 by 60?
Yes.
So where will my quotient be written? Over the hundreds, the tens, or the ones?
Ones.
Very good. Do you see how that's very important? Right? Okay. Now, Dad knows that you estimated that 420 divided by 60 is 7. So he wants to try 7 first. So let's put a 7 over the 0. Then Mom's going to multiply. What's 7 times 60?
420.
420. Very good. Sister will subtract.
0.
What's 430 minus 420? 10. Very good. Now, do we think that's a remainder or can we keep dividing? How do we know that that's a remainder? Well, because it's smaller than the divisor. 10 is less than 60, so unless we add a decimal point and go into the tenths and hundredths and thousandths place, which we're not going to do right now, we know that's a remainder. So here's how you write your answer. It would be 7, capital R, which stands for remainder, 10, and that would be your answer. Now, how can we check our work? It's very important always to check your work. Here's how you check. What is the opposite of, what's the inverse operation of division? Okay, so we're going to multiply. You multiply your quotient by your divisor. Okay, so this is how you check. You always multiply your quotient, don't worry about the remainder right now, multiplied by the divisor. Okay, so what's 7 times 60? Everyone? 420. We want our answer to be our original whole. Is 420 the same thing as 430? No. Because then we have to add the remainder. So then you do 420 plus 10 is what? 430. And you can see that that is our original whole, so we can check and say that's correct. The reason this works is because we take our original whole of 430, we're splitting it into 2 different parts. One part is 420, right? And then one part is 10. Does that make sense? And then 420 plus 10 is 430. We're splitting it into 2 parts. The first part is what we multiply to do the inverse operation. And the second part, we have to add the remainder.